This is a video to help you complete the latent heat of ice experiment. For that experiment we'll need digital scales, a glass of room temperature water, so this is just tap water that has been allowed to warm up to the room temperature, some ice cubes, a measuring cup, an earthenware mug, and a pocket thermometer, some tissue paper, and of course a pen and paper to record your measurements. So the first thing we're going to do is we're going to turn on our scales and we're going to put our earthenware mug and we're going to record its initial mass. In my case, the initial mass of the container is 374 grams. I'm now going to pour out approximately 150 milliliters of water. You don't have to be too precise about it. I'm going to pour that into the container. Now I'm going to record the weight of the mug containing the warm water. So in my case that is 513 grams. Once I've done that, I'm going to take my thermometer, I'm going to take it out of its sleeve, I'm going to place it into the water in my coffee mug. I'm going to let it sit there for a few minutes until the reading on the dial has stabilized. Let's zoom in on the dial so we can understand how to read it, the scale. With this particular scale we can see that the units of the scale are in Fahrenheit, and the major markings, which are the long darker marks on the outside, represent 10 degrees Fahrenheit. I know that because here's 0 and here's 20, and we can see that there's a one major mark between those. So that means that these long lines here, every long line represents 10 degrees Fahrenheit. We can see that between the major markings there are 5 subdivisions, the minor markings. That means that each minor marking represents a change of 2 degrees Fahrenheit. So it's important to see how the scale is divided on your particular thermometer. In my case we can see that the needle, the indicator, is between 60 and 80, so it's just beyond the 70 degrees Fahrenheit mark by one minor marking. Each minor marking in my case is worth 2 degrees Fahrenheit, so this represents a temperature of 72 degrees Fahrenheit. And I'm going to record that on my data sheet. That's my initial temperature, 72 degrees Fahrenheit. Having got the initial temperature, next thing I'm going to do, I'm going to take a piece of ice, I'm going to quickly dry it, and I'm going to drop it into my coffee cup. I'm going to then monitor the temperature. We should see it drop, and I want to record the minimum temperature. We don't want to put too much ice in, otherwise the water will reach 32 degrees Fahrenheit, but we do want to put enough in so that we get enough of a temperature change so that we'll get some good data points. And then just at the point where all the ice melts, that will be our final temperature. So keep an eye on the ice inside the container. Yes, there's still some ice in my container. So I'm going to wait for all the ice to just disappear. Okay, just every now and then just stirring the container, being careful not to touch the lower part of the probe and warming it with my hands. Okay, just got a tiny bit of ice. I'm going to wait for the ice to disappear, and it's gone. So at that point I'm going to quickly record my final temperature. So you can see my final temperature there is 60 degrees Fahrenheit. Finally, we need to determine the weight, the final weight of the coffee mug with the initial amount of water and the melted ice. So let's switch on our weighing scales, put our mug on top and record that final number. In my case it was 525 grams. Those are all the steps required to perform one measurement for the latent heat of fusion of ice, and it's recommended that we repeat this about 3 times so we can get an average value. And that's the end of the experiment.